Hello students, so we are doing exercise 5.3. Next question is question 14. You have to find dy by dx. So sine inverse 2x root of 1 minus x square. So same way you have to solve this. That is, this becomes sine y equal to 2x 1 minus x square. Okay. So differentiating both the sides, so we get cos y dy by dx equal to d by dx of this function. So here product rule applies. So this is u, this is v. Okay. So we'll write RHS u dash v plus v dash u. So u dash is 2 v plus v dash. So derivative of this function. So root is given by 1 upon 2 root of x, right? And then the derivative of this minus x square. So minus 2x, okay, into u. U is 2x. Okay. So we will get 2 gets cancelled. Here 2 is there. So 2 you can take common. 2x. So x, I'll just cross multiply this. So we'll get 1 minus x square. X. Oh, this is not x. Bracket this. 1 minus x square minus this 2 we took outside, right? So x square. Okay. So we'll get 2 1 minus 2x square on root of 1 minus x square. Okay. So this is our right hand side. Then you have to find cos of y, okay, in terms of sine. So I'll write this here. Okay. So LHS cos y is root of 1 minus sine square y. Okay. Sine y is this square. So 1 minus 2x square is 4x square, and square and root cancel, so this is 1 minus x square. 1 minus 4x square plus 4x raised to 4. Okay. So this is again a plus b the whole square formula. So here minus is there in between. So this is 1 minus 2x the whole square. Okay. Square and root goes, so we'll get 1 minus 2x. So this is our LHS. Okay. One minus 2x, 2x square. Yeah. It was 4x square, 1 minus x square. So x is to 4. 2x, 1 minus 2x square. dy by dx, 1 minus 2x square. So this cancels, so we'll get 2 by root of 1 minus x square. Okay. Question 15. Y is equal to sec inverse 1 upon 2x square minus 1. So sec y equal to 1 upon 2x square minus 1. Okay. So we can write this sec y in terms of cos, that is 1 upon cos y, right? So our cos y is 2x square minus 1. Okay. So if I write this terms in terms of x, so what it will be? 2x square equal to cos y plus 1. Okay. So x 2 comes in the denominator and whole root. Right? 1 plus cos y can be written as, so if you take say uh, cos 2x, okay, cos 2x is 2 cos square x minus 1, and there is one more, that is 1 minus 2 sin square x. Okay, so we are using this cos 2x equal to 2 cos square x minus 1. So if I take cos 2x plus 1, then 2 cos square x. Okay, so I'll write this 2x as half angle. So dividing by 2, you will get here x by 2. Okay, so same way, if I write this as 1 plus cos y as this, that is 2 cos square y by 2. Okay, then our x is cos square y by 2. This is x square, so x is cos y by 2. Okay, now you have to differentiate. So d by dx 1 equal to cos y by 2 is minus sin y by 2 into half into dy by dx. Okay. So dy by dx is minus 1 upon 2 upon sin y by 2. Okay. Now again I have to write everything in terms of x. So sin y by 2 you can write it as root of 1 minus cos square y by 2. Okay. So this is nothing but minus cos y, what we have got, x equal to cos y by 2, right? So this is x, 1 minus x. Okay, so this is the answer. This way you can solve it, or you can take the derivative of this function and derivate this. That is, we were doing that way earlier also. Okay, you can follow this also or that also. Both are true. Next is exercise 5.4. Okay, first question, e raised to x upon sine of x. So this is u by v rule. So this is u, this is v. So we'll get dy by dx as u dash v minus v dash u upon v square. Okay, u dash is e raised to x, v is sine x, minus v dash is cos x, e raised to x upon sine square x. Okay, e raised to x you can take common. So this is the derivative. Then we have y equal to sine inverse of x. Y equal to e raised to sine inverse of x. So this is composite function. Two functions are there. Okay. So first you have to differentiate e raised to something. So that is same thing. Then the derivative of sine inverse of x. 1 upon root of 1 minus x square. Okay. Next question is you have to show that the function given by f of x equal to e raised to 2x is strictly increasing on R. Okay, so you have to take two numbers x1 and x2 in R, real numbers. Okay, now x1 is less than x2. Okay. This implies that 2x1 is less than 2x2, correct? So taking the exponential, that is e raised to 2x1 will be less than e raised to 2x2. So we have shown that the function f of x1 is less than f of x2. So this is increasing. Okay. Next question, y is equal to e raised to x cube. Okay. So dy by dx, applying chain rule, e raised to x cube is e raised to x cube into derivative of x cube 3x squared. Okay. So this can be written as 3x squared into e raised to x cube. Okay. Fourth question, sine tan inverse e raised to minus x. Okay. Three functions are there. So dy by dx, sine becomes cos. This remains same. Then we have to take tan inverse. Derivative of tan inverse is 1 upon 1 plus x square. Now here x is e raised to minus x. So square into derivative of e raised to minus x. E raised to minus x and derivative of minus x, that is minus 1. Okay. So you can write this as minus e raised to minus x upon 1 plus e raised to minus x the whole square into cos tan inverse e raised to minus x. Okay. Okay, next question. Log cos e raised to x. So dy by dx, log of x is 1 by x. So this is 1 by cos of e raised to x into cos of e raised to x derivative minus sine e raised to x into derivative of e raised to x is e raised to x. Sixth question is given e raised to x so here they have given e raised to x raised to 5 till 5. Okay. So simple it is. You have to just derivate this e raised to x. This will be, that is derivative of e raised to something into derivative of this function you have to write. So this is e raised to x square. 3x square e raised to x cube. 4x cube e raised to x raised to 4. 5x raised to 4 into e raised to x raised to 5. Okay. Next. Y is equal to root of e raised to root x. Okay. So this is given as y is equal to e raised to root x raised to half. Okay. So dy by dx is, this you can also write as y square, that is squaring both the sides, you will get e raised to root x. Then differentiating, that is you will get here 2y dy by dx equal to e raised to root x into derivative of root x, that is 1 upon 2 root x. So dy by dx is equal to 2y comes in the denominator. So in place of y, you have to write this function. Okay. So this is the answer. Next question, y is equal to log of x. Okay. So this is dy by dx. First you have to differentiate this log. So this is 1 upon log of x into, then differentiate this log, that is log of x. This is 1 upon x. So this is 1 upon x log x. Okay. Then y is equal to cos x upon log x. So this is u by v. So I'll directly write u dash, that is minus sin x v minus v dash is 1 by x u upon v square. Okay. Next question. So dy by dx. You can take this cos. This is a it's say angle, right? So first you have to differentiate cos minus sine, angle remains same, and then you have to differentiate this two. And these are addition. So log x is 1 by x and e raised to x is e raised to x.